Okay, so using the trig identities to rewrite some stuff. So I'm just going to real quickly rewrite what these identities are for the YouTube video viewers, which will probably be 3 of them.
Oh, I commented on
I saw that. That was wonderful. Thank you. Was your comment something about mic her up?
Yeah.
Okay, mic her up. This is why we don't mic you up, because we just wasted time. We wasted more time. Yeah. Okay, so my reciprocal identity is going to rewrite them now. So sine of theta, I'm going to use theta, not u, is going to be 1 over cosecant of theta, cosine theta. It's good to write these all over again so that it's muscle memory. And boom, there they are. So far, so good, right? All right, quotient identities. What are the 2 quotient identities? Tangent equals sine over cosine. Cotangent is so those you all know. The Pythagorean identities, the YouTube video viewers will be a little lost in this one. So if you're watching this video and did not get a chance to view the reasoning why this is true for the Pythagorean identities, Google why is it true, and hopefully you get something that works. So what's the first Pythagorean identity I showed you? Boom! What's the second one I showed you? Equals secant. See, I told you I don't memorize these at all. I had to figure it out. And then the last one was okay, so we're going to be using these identities to rewrite some of the expressions below. I'm just going to tell you right now, there's no like certain order of I should be looking for this first or that second. It really just has to do with comfort and being very comfortable with not only these identities, but algebra. You need to know how to do algebra. Some Yes, you're good?
Yeah.
Cool. We'll find out. Oh, not this class is algebra. Don't talk to you? Oh, okay. Somebody woke up on the wrong side of the bed this morning. Okay. So, why are identities used? Why do you think we use identities? This is just a filibuster until I pull up the actual answer. Why do you think we use identities? To simplify? I like it. Anybody else have anything else? Any other ideas? I mean, like, I don't know what they want you for an answer. I am looking it up right now. That's why I don't get these notes, because to simplify expressions. See, it's stupid. I mean, like, there's more uses to it, but I guess this is what we want for this class. Okay, and here's a side note. If you are stuck, make everything into sine and cosine. You'll see what I mean by that as we get going here. If you're like, I don't know what to do, just make everything into sine and cosine. Like in this first one, we need to simplify this. It's sine of t plus cotangent t cosine t. I don't know what to do. You're great at notes. So it changes cotangent into a, what did we say? Cosine over sine. It's going to give us a cosine over here, and we still have this sine t right here. Okay, let's simplify this a little bit further. How would we simplify this further? What's that, everybody? You do cosine times cosine? That's great. So you're going to get cosine squared of t over sine of t. Okay, you should not have fractions in your answers as we're simplifying, by the way. Fractions should be gone, or they should just be one fraction, if that makes sense. Okay, they shouldn't be like something that's not a fraction plus something that is a fraction. So what can I do now to either get rid of this fraction or make everything as one fraction? Which one? Over. Get common denominators, which means you have to multiply the left one by sine t over. Yeah. Sint over sint. So when you do that, you're going to get a handy dandy sine squared t over sine t plus cosine squared t over sine t. This is so exciting. This is like so many steps to get something that's so fun. It's not ridiculous. This is why you're not mic'd up. Okay, so what do you do now? Add them together, and you're going to get sine squared t plus cosine squared t. Now that looks familiar. All over sine t. Well, what is sine squared plus cosine squared? 1 over sine t. No, what's 1 over sine t? Again, we don't want fractions if we don't want them. So this is cosecant of t. Thin air, you totally could have guessed. Yeah, I guess you could have guessed. Well, sometimes the answer is 1, sometimes the answer is 0, sometimes it's like negative of those. So we just kind of 1 out of 15. Sometimes we have a 2 in front, sometimes it's squared, sometimes it's cubed. What I'm trying to get at is you need to know what's going on. Okay, second one. Again, there's a couple ways to do it. You could change everything to sine and cosine. If you're stuck, I advise you don't do that right off the bat, because sometimes there's a much easier, quicker thing to do here. Right, but I don't know if we're stuck yet. Are you already stuck? Well, luckily your teacher knows like some like techniques here to get us unstuck before we have to do that. Because you can change everything to sine over cosine, but it's going to be a lot of steps. There's going to be a lot more than this one. Okay? What I'm going to do here is I'm looking for a GCF. Is there a common factor for each of those? Yes. The reason I'm doing that is because this cosine squared is like screaming at me. Like I probably need to get a Pythagorean identity somehow. So I need to get rid of this cosecant, and luckily that's also a cosecant over there. So if I have a GCF of cosecant of x, what's left on the inside then? So I'm left with just a cosine squared minus 1. Okay, so is there an identity for one of those? Okay, so cosine squared minus 1. Yes, so this one's super close. This one is not going to equal a positive sine squared. But if we throw the cosine over here and then negate each of those, you're going to get a negative sine squared. Okay, so this is going to give me a negative sine squared x. And I still have the cosecant of x. And this is probably more like the, okay, I'm stuck now. Because you really want to get this down into just one term, no fraction if possible. Like, that's what we're trying to do. So we're kind of down to one term, but we can simplify this further. What can we do? So 1 over sine times negative sine squared x. What happens there? And so what happens when you multiply it through? And then what happens? Yeah. So that sine x cancels out with that, and left with negative sine x. And that's it. This takes a lot of comfort. You need to get comfortable with this stuff. You need to practice. You know how like we tell you like, yeah, you need to do like your classwork outside of class, and we all just like laugh at each other. Ha ha ha. We know it probably doesn't happen. You really probably should do it. Some of you are like, I actually do that. I'm like, yeah, that's why I get good grades. Yeah. What? This is so important. No, you won't.
I do watch your videos. All you do on your weekend is pre-cal homework.
Me? No. I have a life. But yeah, you can go.
Yeah.
Back in my day, when my school said we have to have homework, I did it. Actually, I never did homework at home.
No, yeah. Aren't we like, there's a no homework policy?
Kind of, sort of. Kind of, like yes and no.
And math. Have you ever had a math class with pre homework at WebAssign? Not like required homework. Yeah.
Well, you have a WebAssign.
Yeah, but that's different. But like AP, no, that's different. But like every worksheet they give you is optional. Yeah. And it's never graded.
It's a lovely system. Alright, any ideas here for 3?
We can take out the...
It's like the exact same problem.
Oh, that's a common.
So divide the whole thing by sine x, and you get sine x times cosine squared x minus 1.
You must be so angry at the math.
Did you hear me? I hate this class. That was for my mic.
Daniela now hates this class.
Now.
Is now expressing that she hates this class. Come on, this is your favorite class of the day. Wow. That required an adjective.
Yeah, it did.
Or is that an adjective or is that an adverb? I don't know my English.
It's an adjective. It would be a verb? No. Yeah. A verb.
What is it? Luckily you said the PG word, so I...
Describing the...
It's an adverb.
But it ends in ing.
Alright. This is why I don't like English, because we're all right, but yet we're all wrong. I would say somebody looked that up, but that's probably not a good thing to put on the Google in school. And Daniela goes for it.
We got my VPN. I always have my VPN.
Alright, let's cosine squared minus 1.
Where did you get that? Oh, from what?
Who just said the correct answer? Yes. What is it? And there's nothing else you can do. I know, these problems are so exciting. I love them. Oh my gosh.
And there's a whole back page.
Yeah. I mean, I'd rather have you like practice these than. Do we want to do 4 or? Yes. Okay. Me. Okay, 4 is just like number 1. You want to try 4 on your own for a little bit here? 4 is super similar to 1. Did you changing everything to sines and cosines? And then do you have like 2 fractions possibly, or like 1 fraction that you need to combine? Did you make it into 1 fraction? And then you should be able to do a Pythagorean identity after that. It is a nice clean answer if you're wondering. It is a very clean answer. What'd you get?
Oh, okay. Is it this? Sine 2t over sine t.
What'd you just say?
Sine squared t over sine t.
Which is equal to?
Sine
T. Wait, so what's the answer? Sine what? T? You get sine of T. Okay, so you're stuck again. Just change everything to sine and cosine. Combine it. Make it to 1 fraction, Pythagorean identity, and then just simplify and bam, sine of T.
It's the one that like girls be worried about. Did I not save it? I'll cry if I didn't save it.
Are we good?
No.
No?
No, I deleted it. It's too big.
Alright, the next one. Okay. So, I have a strategy for these, and it has worked so far in my mathematical career 100% of the time. I'm waiting for it not to work. What's that? Well, no, I'm just saying, it's so... Well, if it doesn't work, then you're going to be like, oh my gosh, it didn't work. Well, you should know if the problems don't work. Like, the techniques don't work. But whenever I see this 1 plus cosine, or any, like, 1 plus 1 minus whatever, I just multiply by the reciprocal. Top and bottom. And it has always worked out, and it's always been a lot less steps. My entire mathematical career. So, in this case, not by or sorry, that's the reciprocal, the conjugate. My bad. Wrong math word. Conjugate. Okay, so conjugate is when you just change the plus sign into a minus sign, and everything else stays the same. That's the conjugate. It usually makes everything super easy and super simple. Okay? Trust me, because I'm even looking at this one problem we're doing, and it's got like 7 steps on the key. I think I can knock this down to like 3 or 4. Okay? Multiply by the conjugate. So what's the conjugate of 1 plus cosine? So I'm going to multiply this by 1 minus cosine. This is not the only way to do it, but this way has like always worked. So the great thing with doing the conjugate is what happens at the bottom now. It becomes 1 minus cosine squared, and why is that going to work out in my favor? That's a Pythagorean identity. Okay? So it's going to be 1 minus cosine theta sine of theta. Do not distribute that. Just be patient. Be patient. Because I'm just telling you right now, whenever you do the conjugate, be patient. I hope some of you are starting to see a couple steps down the road what's going to end up happening here. Okay? What does 1 minus cosine squared turn into? So this is going to turn into a sine squared. Now, why do I have to be patient? Because what can I do now with this sign on top? That sign on top, so I'm going to cancel out with one of the signs on the bottom. So I'm left with 1 minus cosine theta all over sine theta plus cosine theta, which they now have the same. Not 1 minus cosine squared. Don't forget we're subtracting cosine, adding a cosine, which turns into a just 1. So if we add it, if we have a negative cosine and add a cosine, we just have 1 over sine, which is alright, and I don't know if some of you can see like the monitor. If I let it close up, I'm going to zoom in a little bit. It'll ever load, and I can show you like how much work it was not to do that. It's not loading. That's how much work it was. Oh, there it is. There. Look at all these fractions. For those of you that can see it. Right? Totally not cool. There, I'll show you. I guess I can always just do this. Like a lot of that work they did doing it a different way, which is totally fine and it works. But
So which way did they do it? Did they just turn everything into sine?
so they multiplied this by sine, this one by 1 minus cosine, or sorry, 1 plus, and then you have these big fractions, and then you can get lost in the shuffle, and then you have to figure that out. This is sine squared plus cosine squared. I mean, I think that's a lot more work. I think if you just do the conjugate and just used to that technique, it's pretty easy. Okay, so let's go ahead and look at 6. So, what am I going to advise you to do on number 6? By the conjugate, which is actually the only thing you can do anyway for this one. So I'm going to get 1 minus sine theta all over, I'm going to get 1 minus,
Why are you doing the other side too?
because since I have a 1 plus and 1 minus, I need to do both of them. Because they're both going to turn into what then? So what does that 1 minus sine squared theta turn into? Cosine.
Why didn't you just cancel it out?
Because you add fractions, you gotta keep the denominators. So now, I'm gonna get 1 plus 1, which is 2, negative sine plus sine, which is nothing, all over cosine squared theta. Oh, can I rewrite that nicely? don't worry. No, you're not flipping the 2. The 2's still there. Secant squared. I should do that the entire test. Like, you guys are testing, I should just go through. All right. Cosine? Also could be cosecant or cotangent.
You know that there's a school that got busted for doing that, like, star testing? Like, teachers would wear, like, patches on their clothes and they would point at it, and, like, whatever color it was the letters that they would put on the test so that they would have higher scores. What?
Yeah, let's just risk our because as teachers you get fired for doing
No,
that.
but that's like an
Obviously.
actual thing. You didn't hear about that story?
No, I don't read about the dumb stories.
It was a while ago. It was like 5th graders.
Did 5th graders get in trouble?
No, they can't get in trouble. They.
Know that they weren't allowed to get help. It's not communicated. I don't know. The trees weren't exactly the brightest. They like would point at something, but they weren't like. Yeah, they weren't like.
All right. Okay, any ideas on this one? There's a couple ways different ways to do it. I'm looking at the way that this person did their key, and I was like, oh my god, you did it the longest way ever.
Well, we could divide the whole thing by cosine.
4 to the 4th power.
Why are you saying cosine
Oh no,
before?
the cosine in the middle. The cosine in the common denominator. I mean, in the common factor.
GCF?
Yeah.
You can totally do that.
Why wouldn't you do that?
You
Tell
can't.
me why
Fine.
you
We'll just do. We'll do it. We'll do it. We'll do it.
I guess you could also take the tangent and turn it into.
Whatever. We're doing it this way. We're doing it this way. Yes, I just did simple math. GCF. Do you see an identity there?
Yes, it's secant too.
You can't square.
I'm sorry.
You should be. And when you're in doubt, what's secant squared equal? 1 over cosine. So we're going to get cosine squared x times 1 over cosine squared x, which is canceled out and gives you an answer of 1. Good job, Danielle. I'm glad we went that route.
Was it not good enough for you? There is a simpler way to do it. Okay, tell me the simpler way then.
All right, what's a different way, people? What if you just write this tangent as sine squared over cosine squared? Then those cancel out right off the bat. So that's your step 1. Cosine squared plus sine squared is equal to? That's okay. We're good. We're good.
Okay, see, but I wouldn't have known that on the test. So I would have gone for the other one.
And it worked out for you now, didn't it?
I mean, kind of.
Let's just get angry at each other about this. All right, number 8. Any ideas?
Can we put up the top into
We can, but I'm going to stick with the thing that has worked for me my entire career of math. Conjugate's going to work. What's the conjugate of cosine x plus 2? It's clearly Friday. And so what happens at the bottom now? And again, don't distribute the top. Be patient.
Why is it just plus 4? Minus 4.
Because since it's the conjugate, it's super nice to just square the front term and then the back term. And it's a minus sign.
Why isn't it plus 3?
We didn't show that step. Okay. So if we were to distribute this, it's cosine times cosine, which is cosine squared.
Yeah.
Then it's going to be cosine times 2. minus cosine times 2. So those go away.
Okay.
And then negative 2 times 2 is a negative 4. I'm doing it right now. You notice my patience here? Why is the patience pay off and not to distribute it? It just conveniently whoop goes away and I'm left with. And there's nothing else you can do. What's up? Okay, could you do difference perfect squares up top? Totally could. Works out. It could be left with the exact same thing. But I have seen problems where if you do that, it doesn't cancel out enough, whereas reciprocal conjugate, it has worked 100% of my career. I'm waiting for the first problem where it does not work.
I'm getting trying. It's easier than your nonsense.
What? Okay, there's more than one way to do all these problems, okay? Can we just get over that? Next. I'm just trying to teach you the most consistent way to do it. That's all I'm trying to do. I'm trying to be consistent. Okay, hey, I'm going to skip 9 because it's the exact same problem as 6. I don't want to waste your time. I want you to practice some of these on your own. So let's go ahead and try out 10 here. Any ideas for 10? So you're already flipping these. No, it's a fantastic idea. It's just, I don't know if people are going to get it. I like it, but if we're not there yet, what if we just write this as 1 over sine theta all over 1 over cosine theta. You multiply by the reciprocal and you're going to get cosine over sine, which is that's really tough. It's really tough. It is really tough. I actually even hate it because no, this is a stupid problem. I'm not doing it. No, this is stupid. No, okay. If you want to see what the answer is not simplified. That's why I'm saying it's stupid. That's the answer. It's not simplified. It's stupid.
What is it?
If I give you a problem that's in the test and you're right, this is stupid, and I agree with you, full credit.
What is this? What is it?
Right, but I have to agree with you. Yeah, because this one's already simplified. The person in the notes did the problem and realized, oh, it's already simplified. I wouldn't give it to you.
They work backwards to make it more complicated.
Who writes this? I'm trying to see. I don't think it's Ben Schneider's handwriting. It doesn't look like it. Not really.
It's not his writing.
It's not his writing.
Alright.
I know his writing. I see it.
For those that flew you on YouTube, they couldn't see that. Just look at the key on canvas. It's stupid. I'm not going to ask you that question. We're done.